Hello everyone and welcome back to the next Snap lesson. Today we'll be starting, or we'll mainly be doing a lesson today, but we'll also start the art project, which is our next project in this course. Okay, so the project that we're going to start is basically drawing really interesting art with the pen tool. So we'll basically mainly be using the motion tools, or the motion blocks, the pen blocks, the control blocks, and the variables blocks. We've already gone over the motion blocks and the control blocks, so in the next classes we'll be going over the pen blocks and the variable blocks. Okay, so first, before we do some actual Snap stuff, let's go over some more basic stuff, which is basically an introduction to data types. So we talked about how computers use data, but for a computer, it's useful to know what kind of data the computer has to deal with. For example, the computer might be dealing with an integer, a floating point number, a string, a letter or a character. We already talked about booleans, a true or false value, etc. So for people who don't know what an integer is basically a number that is a negative number, a positive number, or zero. So for example, -5, -2, 4, and 10. A floating point number is any number that's a decimal. So for example, -5.0, which is essentially -5, -2.3, 0.5, 11.9, these are all floating point numbers. Finally, here's another data type that we'll talk about, which is strings. Strings are essentially a collection of symbols or characters, or chars or characters. So for example, hello there is a string, and 1, 2, 3, 4 at is also a string. Just as a fun fact, all of these are known as data type. Okay, so just as an activity, you can pause the video here and think about what data types each of these following pieces of data are. Okay, assuming you've paused the video, the first one is going to be an integer. It could also be a float, but it's essentially an integer because it's just a number. For example, 11 is just an integer. It's either a positive number, a negative number, or 0. The second one is a string. We can tell because it's wrapped in those in quotation marks. And when we use quotation marks, that is to refer to a string. So 1, 2, 4 would be a string. Even though it is a number, 124 is a number, but because it's wrapped in those quotation marks, it's actually a string. You can see that on the last slide too. Both of those examples were wrapped in quotation marks. Okay, the third example is 1.0. This is a floating point number. It is not an integer, even though it's 1 is an integer. It's not an integer because for a computer, it has a decimal point, so 1.0. Because of that, it's not an integer to a computer. It is a floating point number. Okay, so what about your name? Well, your name is a collection of symbols. The symbols are the letters of the alphabet. And so your name is a string. Your full address is also a collection of symbols because it has some numbers for like maybe your house address, and it also has the street name, for example. So it has some letters and other symbols. So it would be a string. Finally, your birth year is an integer because it's just a number. Okay, so let's talk about data types in Snap. So Snap is really cool because it can actually automatically identify data types. So in other languages, we might need to, for example, specify that something is an integer or something is a float, but in Snap, it just figures it out for us. So for example, here in this code, we have say hello for 2 seconds. So snap interprets hello as a string and 2 as an integer. And so something to note is that reporters, so the oval shaped blocks, usually report integers, and the square shaped places where you can type are usually for strings. Okay, so now let's talk more about integers and floating point numbers. So we can see that any location in Snap where you can use an integer, you can also use a floating point number. And any place you can use a floating point number, you can use an integer. And that's because they're both numbers. Because, for example, if you have a number line, you can point to them on the number line. They're both numbers. So since integers and floating point numbers, floating points are just decimals, remember. So we can use them in both cases. Like for example, you could move 10 steps or you could move 10.5 steps. Each of these will both be perfectly fine in Snap. However, you can't say something like move hello steps. That doesn't make sense. Okay, so now let's talk about variables. So variables are used to hold some kind of data type that you want. And they're essentially a way to store and hold information. Okay, so we've already actually gone over one variable, and that is the answer block. So when you use the ask block, you generally use the answer block to retrieve the answer that the user typed in. So for example, in that GIF, the user typed in Aathreya and then Prasad, and then that got stored in the answer block in each of those cases. So essentially in this problem, or in this code, essentially what's happening is, first the computer, or the Snap code, is asking the user, what is your first name? The user is then inputting their first name, Aathreya. And this name is being stored in the answer block. After it is being stored in the answer block, it is being retrieved when we use say answer for 2 seconds. The reporter answer essentially report the value of answer. So you can see how this variable answer is essentially really good for keeping that information and reusing it later in the program. Okay, so now we've already gone over the ask block, but try writing a program to ask the user for their first name, store this in a variable, ask the user for their second name, and then say their first name and their second name. So this is exactly the code that was on the last slide, so don't go back to the last slide and take a peek. Instead, try it yourself and then compare how you did with the actual code. So for the people who actually get it really quickly, you can try this extra challenge. Rather than using the say block to say the first name and then the second name, try using this join block to join the two names together and then say them in the same say block at the end. So for this, you might have to use more than one join block, which you will see when you try. Or you can realize that you can actually use those black arrows to add more fields to that join method. Okay, so assuming you've tried that and checked your answer with the previous slide, and if you haven't, you should pause the video now and go try that. Let's now talk about functions. So we just talked about variables, and functions are essentially a way to take data and do something to that data. So accomplish a certain task. So for example, one function of your fan is to blow air and cool down your area. So what do you think a function of your bookshelf is? You can think about that for a second. And one function of a bookshelf is just to hold books. Okay, in programming, a function is a set of organized, repeatable code that is used to do something specific. So we generally use functions to do something, and we take in some data and then we output some data. So this is essentially a way that we can abstract code. What that means is we take some code and we write it in this function, and then we can use the function to do all kinds of different things. So that might not make too much sense, but for example, if you if you have a function that adds two numbers like a and b, like you could, for example, say function 1, 2, and then it could add 1 and 2 together to get 3. You could maybe put in 5, 4, and then it comes out with 9. So you can essentially make functions to do all kinds of things, but we'll see more examples in the next few slides. Okay, so here's a good example that we can use to get a better understanding of all the concepts that we're just talking about. So essentially, your teacher is absent and we need a robot to collect attendance. So if we want to give this robot instructions on how to take attendance for a class, how would you do it? Okay, so you can take a few minutes to think about that and pause the video, and then we'll go over it together. Okay, so assuming you've paused the video, let's start with this. So you want to give the robot some instructions. So you might have thought of something like this. First, read the first name on the list, then call that name. If the student responds, then mark them as present. Otherwise, mark them as absent. Then read the second name on the list, call that name. If the student responds, mark them as present. Otherwise, mark them as absent, and so on, until you read the last name and you're done. Okay, but this seems like a lot of work. Think about writing out this list in order. You would have tons of steps. Just think about it. Let's say you have 26 students in your class. Each student, you have 4 steps. That's already 104 steps. You're gonna have to write out 104 lines just to make the robot take attendance. But as a programmer, we're lazy. We don't want to have to keep writing out these same 4 lines again and again and again because they look exactly the same. Like, for example, look at that. Line 2 and line 6 are exactly the same. Line 3 and line 7 are exactly the same, and line 4 and line 8 are exactly the same. Even line 1 and line 5 are almost exactly the same, except for the fact that the first line has the word first, whereas the 5th line has the word second. So can we somehow make this easier to write out? And so yeah, this is essentially what we noticed. If we look at the blue part and the green part, they're exactly the same. The only thing that changed was going from first to second. So let's now create some kind of function called check or something. So this function essentially does that block of code all in one little function. So the check function would take in some variable I, which is for the number of the student. So for example, first, second, third, so on. So our first step is going to be read the ith name on the list, call that name. For the second step, then if the student responds, mark them as present, and then otherwise mark them as absent. So that's our main procedure. Now the only thing that's changing is the number of the student. So first we're checking the first name, then the second name, then the third, and so on. So now if we define or we write check ith student is this red piece of code, or not necessarily code, but since we're working with a robot, I guess it's code. If we use check ith student to mean that block, then we can just write check first student, check second student, check third student, and then write that again. And now look at that. We went from having to write 104 lines to now we just have to write 26 and then the additional 4 lines to define what the checking is. So 30. We went from 106 to just 30 lines. That is a huge difference. So we can see how writing a function could be really, really useful. Okay, so if we want to actually talk about this more in depth, a function, if we wanted to express what this would be almost as a function, check would be the name of the function. And I, the variable that we put into the function, would be an argument. So an argument is essentially a variable that we put into a function. So remember that we use variables to hold data? Here, this variable essentially changes, and every time we're changing the variable. So we start with I equals 1. So when I is 1, we check the first student. Then when I is 2, we check the second student, and so on until we get through all the students. Okay, so now let's try thinking about how this would work in Snap. Okay, so in Snap, a function is a set of statements or blocks of code that do a specific job or calculation. So you can do all kinds of things with functions like drawing, getting information, finding out if two words are the same, moving your sprite or character across the screen. You can do basically anything you want to imagine. Okay, so a function can do a lot of different things. So for example, here we have this arrow or the general sprite just making a house sort of figure. And then on the right to that, we also have the arrow just gliding across the screen. We could have a function just to do that. And in fact, there already is a function just to do that. It's just a glide function. It's just that that function already exists in Snap. So you might be wondering, aren't all the blocks that we use in Snap just functions? And you would be right. All the blocks that we use in Snap are functions, and they essentially do something with the sprites. So on this page, you can see all kinds of different examples of how we could use functions to make certain actions or repetitive actions more easy to do. Okay, so just as we just said how all blocks are functions, we can actually classify these. So we have commands, reporters, and predicates. And these blocks are all functions, but they're slightly different. So for example, a regular command just does something. It doesn't give anything back to you. So it takes in some data. For example, here we're putting in that variable 10, that argument, which is an integer, and we're putting in 10 into this command, but we aren't getting back anything from the command. The command is just moving that sprite across the screen. It doesn't actually give anything back. Then we can have a reporter, which actually gives us back some value, like an integer or a float. So it takes in information, performs something with that information, and gives us the result. Then we also can have predicates, which take in some information, evaluate some stuff, and give us either a true or false value. So a boolean. Okay, so now we can watch this little animation for making our own functions without parameters. So essentially, we can go to the bottom of or if you didn't miss the start of the application, you could have seen that essentially click that make a block button, and then he made a block. So this block can essentially make the sprite do something. So for example, we can see he made a block, made a name for the block, which is essentially the name of the function. Then you define the function by adding a sequence of blocks that you repeat. So for example, this is almost like that check function that we made for the robot. You apply to save your changes and then click OK. And then you can use that function like a regular block. It's your own block, you just made it yourself. And you can see how it actually works. It moves or dances by moving and turning. Okay, so what if you want to now make something with parameters? So this time you have to do the same steps as first, but now we change to a reporter, and this time what we're going to do is actually click that plus button and add inputs. So for example, number is a variable and it's going to be in an argument of that function. So you can see how now this variable or this function or this block or this reporter essentially reports a certain number. So for example, it just gives back the number. So when we click, it's just going to say 5 for 2 seconds. So you can write really simple functions like this one, or you can write really complicated functions depending on what you want to do with your code. Okay, so now let's take a break from functions, which might have been a bit confusing, and look at some pen stuff. So the pen tool is used to draw on the screen. So we have a bunch of different blocks that we commonly use in the pen section. Clear is for clearing the stage from pen marks. Pen down is for making the pen touch the stage. So if you imagine the sprite having a pen attached to it, the sprite is lowering the pen so that it touches the stage. There's also the pen up, which makes the pen stop touching the stage. Then setting the pen color, which sets the pen color. You can set the pen size, change the pen size, and you can also do something called stamp. So stamp is used to essentially stamp the sprite onto the stage. So for example, it puts an image of your sprite down onto the stage, almost like a print. Then we can also have fill, which is used almost like the paint tool or the fill tool in a lot of these image editors that you might use. Finally, there's also the write tool or the write function, which you can use to literally write on the stage. So you can see how you can type hello onto the stage with different font sizes. So you can see how set pen color to. If you click that box, that black box with the color in it, you can custom pick any color that you want. You can also, if you want a specific color, you can move the mouse to go over that color and then click, and that'll save the color to that block. Also, based on your knowledge of predicates, what do you think that the pen down predicate does? Okay, so if you've given a bit of thought to it, you might just guess that it gives you a boolean true if the pen is down and false if the pen is up. And yep, that is what it does. Okay, so now let's talk about for loops. So remember how we had to say check first student, check second student, check third student, and we still had around 30 lines of code. So that is pretty good in terms of an improvement from 104. But as programmers, we're still kind of lazy. Like, look at that. We have so much repetitive stuff. We're literally saying check student again and again and again. The only thing that's changing is that variable I, or that variable 1, 2, 3, 4, 5, all the way to 26. So we can actually use for loops to work with that. We can let the variable be I, so let's name the variable I. And what this for loop essentially does is, for each of the values from 1 to 10, it's going to evaluate something with the variable I. So if we change that to 26, from 1 to 26, and then we just said check ith student, now the robot will be able to go through every single student in our class. And all we had to do was write those 2 lines of code. For I equals 1 to 26, check ith student. And so look at that. We went from 104 lines to 30 lines, and from 30 lines to just 2 plus 4, or 6 lines. So now we're writing 6 lines of code to have the robot check the attendance for our entire class. And not only is this code shorter, but if we want to, for example, add a lot more students or reduce the number of students, all we have to do is change that one number from 1 to, instead of 26, we could say 34 or 15, or we could change that one number, and that changes the program and allows us to make it work for any number of students. So not only did making the number of lines shorter make our code a lot easier to write out, but it also made our code a lot more abstract, a lot more general, so we could use it in a lot more cases. Okay, so going back to the context of for loops can essentially run some code for each value of I from the starting point to the ending point. It's useful for going through lists like the attendance bot, and it's also useful for a lot of other things where we want to increment a value again and again. So here we can see the final 2-line instructions for the robot. For I, from 1 to size of the list, we're just going to check the ith student. And you can see how we just replaced those 26 students with the size of the list. So for example, we could create some kind of list with the students, and then we just go from 1 to the size of the list, which would be the list size, and then we check the ith student for each of those. Okay, so now let's try to practice, because by practicing these skills, we'll be able to get a better grasp of exactly how they work. Okay, so to prepare for the project, create a function in the pen category called line. So to do this, you're going to have to take in 4 floating point arguments, or integer arguments, x1, y1, x2, and y2, the coordinates of the endpoints of the line. Then put in code to draw a line from x1, y1 to x2, y2. So if you're struggling on this one, essentially you might want to take the pen, put it down, then go, or first before you put it down, put it up, go to x1, y1, put it down, go to x2, y2, and then put it up. That's essentially what you need to do. And if you do that, you'll be drawing a line from x1, y1 to x2, y2. Okay, so that was pretty hard, but here's another challenge. Make a function that takes one argument, which is a list of numbers. Then the list should have a list of coordinates, and for every 2 coordinates, move to that point with the pen down. So this will draw a line through each of those points in the list. So you're going to need to use for loops for this problem, and we'll probably go over it. Okay, so here's a sneak peek at the challenge. We'll go over this next class too, but also try to look at this outside of class. So essentially what you're going to do is, let's say you're given some list, like here we have 50-50, 100-100, 150-50, and then 50-50. So it's essentially a triangle. Essentially what you're going to need to do is pick the pen up and go to the first point in the list. So item 1 of the list and item 2 of the list. Then put the pen down, and you're going to have to read the coordinates in 2 at a time. So we're not actually going to loop on I from 1 to the size of the list, but we're going to loop from 1 to half of the size of the list. So we also covered the first point, so we go from 2 to the half of the size of the list. So we go to each of those points and then pick up the pen. So by doing this, we draw a continuous segment between each of the points in the list. So just another fun fact is that using a loop here is called iterating through the list. Okay, so that is all for today's lesson on Snap, and so we hope you enjoyed it, and look at that challenge problem outside of class as well. Thank you, and we hope to see you in the next lesson.